Back. There you go. Cool. No, don't. Did you eat food? See, this is good, because I ask a question and you actually respond, which is amazing, right? Especially considering that most of my questions are just yes or no. So this is good. Let's try another one. Did you have coffee? Okay. Do you know Kotlin? Okay, that's good. So how many of you, now this isn't a yes-no. This is more of a raise your hands. How many of you write Kotlin code today? Okay. How many of you don't write Kotlin code today? Now, okay, wait. No. Raise your hands. Keep it up. Right. Now, keep it up during the whole session. And that will teach you a lesson that you write Kotlin code, okay? Right, so I'm going to show you a few more advanced features of Kotlin in this talk. It's not too advanced, it's just some things that are not often covered in the introduction talks. And we're going to start with delegation, right? So if you're familiar with delegation, so we have this thing in Kotlin which is called, live coding. This is where it all goes horribly wrong. So, main. I have a class. The class name is class. No, I'm joking. It's called controller, okay? So I have a repository, which is of type repository, right? And we're going to import the Corba repository. Oh my God. How many of you remember Corba? That was horrible. That was worse than decom. So I have a type repository, right? And then I have let's say a fun get index, and then the index is going to do repository get all, for instance, and do something with that, right? So let's create a member function there. It's going to be abstract. So now this, I can kind of inherit, you know, if you're using a dependency injection, you can add the late init here, so that you say this is instantiated via my IOC container, for instance. I can also kind of pass this in as a repository, and learn how to repository. Okay, and learn. So the point here is that I'm passing in a dependency injection, a dependency by the constructor, and then I could do something like, you know, instead of late init, I could assign this in the kind of like repository, this repository equals repository, right? Now that's a lot of ceremony. So in Kotlin we have first class delegation, which means I can essentially say repository by repository. And what that means is that I can get rid of all of this code. Now this disappears, there is no repository, and I can just do get all, right? And it's referring to the get all injected by the repository, first class delegation. Now people sometimes say, what if I have 7 classes? How do I know what is coming from what? You don't have 7 classes. You stop there. You have 1 class, you stop. Someone says, let me, nope. You say, but you, nope. 1 more, nope. You stop with 1. Okay? So we have class delegation, but we also have property delegation. So I can say val my string by some function. And the benefit of this is that I can take this out of my class, right? So now I can delegate the functionality, the implementation of a specific property somewhere else, and then I can reuse that functionality somewhere else. And that's the idea behind property delegation. Now, we have a bunch of built-in delegations, so you don't have to write this over and over again. In fact, one that we have, which is the lazy, right? And this is a higher-order function. Everyone familiar here with a higher-order function? We'll go into a little bit more detail later on, but this is a higher-order function. So this essentially allows me to say that this property is lazily initialized, which means that when I instantiate a class, for instance, or whatever, when I call the function, until that function doesn't actually call that property, it's not going to be initialized, right? So if I have that in a class, it works well, because until I don't access that property, it won't be. And when it's initialized, it's lazily initialized. And then it'll just be accessed once when it's initialized. And that's built in. And all I have to do is pass a function that actually resolves that. But I don't need to take care of the lazy sequence, initialization, synchronization, any of that. So the lazy function, the init function here, is basically a function that is writing println init late run. There's another one that we have built in which is kind of nice, which is called vtobal. And vtobal, essentially what that does is, again, it takes a lambda and says, in this case, it's saying that only set the property value if the condition is true. So in here it's saying that only set the property value if the value that I'm being passed in, the new value, starts with the letter S. So in this case, I'm instantiating the class, and then I'm printing out the value of the property, and then I'm changing it to change, right? Changing it to change. Because change doesn't start with S, the value is not being printed out. See here? It's not being changed. When I change the value to strange, because strange starts with S, then it does set the value. There's also observable. There's a whole bunch of properties, delegated properties, that are built into the standard library, right? Not null, vtobal, etc. Now, if you want to go a little bit further, you can create your own delegated properties. And essentially what you have to do is define two operators. One is getValue, which is the service class is passing in the property values, information about the property, and setValue, which is, again, the two first parameters are the same, and then the value, which is the actual value of the property being passed in. Now, some things we've seen here are higher-order functions, right? And higher-order functions in Kotlin are easily defined. It's very simple. So it always follows the same pattern. And it's nicer in that it's different to something like Java. In that Java, you have like by function, you have different interfaces defining functions with different number of parameters. In Kotlin, we always follow the same signature. I have the types of the parameters and then the return value. So if I have a function higher order, no params, that would be essentially op, no params, returning unit, right? Which is nice. It's always the same. If it's a single parameter, I give the parameter name, returning the value. So we have higher order functions, and then I can call these higher order functions using the name of the function, anything that matches the signature. So in this case, the higher order function takes a function that takes a string and returns a string. So this lowercase matches that. This is a single expression function. So when a function can be resolved to a single expression, I don't need to explicitly put the type, and I don't need to have the curly braces. I can essentially write it all on a single assignment, right? I could, of course, create other things like higher order and string, and then here pass in a lambda. And lambdas in Kotlin are defined as so. X, X. I suddenly became Spanish there for a second. X. X. X to uppercase, right? That's a lambda. And if you're not familiar, with Kotlin, when the function has a single parameter, I don't have to explicitly put the x whatever equals x. I could just put it, right? And refer to that single parameter as it. So a lot of the functions in the standard library are actually extension functions. They're higher order functions, but they're also extension functions. So what are extension functions? Extension functions, you've probably seen this. This is one of the nicest features of Kotlin, which essentially allows you to extend the type with new functionality without having to inherit from that type. So here I'm extending string with a new function called toTitleCase, right? And then you can do something like something is the same as something else, or something, and is the same as, what is that? That is also an extension function. Difference is that it's got the infix operator. What does the infix operator mean? That I can call it in infix notation. But I can still call it in normal notation as well. So these higher order functions allow us to basically pass functions along functions along functions and constantly use functions as primitive building blocks. And you might start to wonder, okay, how does this actually impact performance? Obviously, every time I'm calling a function, it is adding to the stack trace. So one thing that you can do in Kotlin is have inline functions. And in fact, the standard library, by and large, is composed of many higher order functions that are marked as inline. And what inline means is that the function is going to be, wait for it, inlined. Which means, essentially, it's going to copy-paste the code of the function to where the function call is, right? So here, what I would be doing is copying, pasting the entire body, including the lambda, to where the function is. Now, if you remove this line, no inline, this is inline, and the lambdas can also have a modifier which is called no inline. And if I add it, it means that that specific lambda of that specific inline function, I don't want inlined. If you do that, the compiler is going to give you a little warning, and it says, the expected performance of this inlining is minimal. It doesn't make sense for you to inline a function and the lambda that you're passing in not inline. So in these cases, it doesn't make sense. The only case where it makes sense for you to pass this modifier no inline is if for some specific reason you have another function, for instance, int to int, right? And this one you do want inlined, but another one you don't want inline. But otherwise, there is no performance gain. So if there's no performance gain, why would we also inline a function? And that's got to do with reification. So in Kotlin, Kotlin runs on the JVM amongst JavaScript and Kotlin native. And on the JVM, you know that we have type erasure, which means that when I have a list of t, I can't query at runtime what that t is. It's gone. It's vanished. Poof. So one of the things that you can do is when you have an inline function, you can actually add a parameter called Reified, right? So without this, first of all, notice that I'm getting the warning saying you are not gaining anything by not adding this inline to this function. And notice here I get an error. It says cannot check for instance of arrays type. But what I can do is add the Reified modifier here, which means that now I can query. It does provide me with information at runtime of that type. And the warning goes. And that is the case in which we want to use inline functions not for performance gains, but for reification. Now, if you use this for reification, you need to reificate all the way down. Right? It's like turtles all the way down, reification all the way down. Because otherwise, at some point, you're going to lose the value. Inlining functions also has certain side effects. So let's take this function over here, right? Containing function. And I have numbers from 1 to 100, right? I'm defining a range, and then I'm saying for each If it's divisible by 5, then return. Print line hello. Okay? That's my function over here. Now, if I run this, what do you think the output's going to be? Say something, please. Even if it's, I want more coffee. Like, just literally say something. Say something. What is it going to print on the screen? Something? Nothing? Nothing. Nothing. Why nothing? Because it's in... Why nothing? Why nothing? Why is this nothing? It's nothing because for each is what? It's an inline function. So it's copying, pasting that function call. Thus, when it calls return, it is returning to the calling function block, which is the outer function block, and essentially comes out. So, in fact, here is an example of my for each. And notice that if I remove the inline, this no longer compiles, because it says return is not allowed here. So these are non-local returns. What happens if I actually do want to reach print line hello? There I can use labels. And I use the label, which is essentially the name of the function from where I'm calling, right? The name of the lambda. So here I do for each. If I want to go and define my own label, I even can define my own label. And in this case, it is going to return to the actual local call. This will be a local return. Now, in Kotlin, we have anonymous functions and we have lambdas. And a lot of times, people usually say lambdas are anonymous functions. In a way, they are. But in Kotlin, we also have anonymous functions, which is kind of like anonymous functions in JavaScript. This is an anonymous function in Kotlin. It's a function with the word fun, but with no name. An anonymous function behaves differently than a lambda. So in this case, the return is going to actually be a local return. And I don't have an at or a label or anything like that. Okay? Did someone say okay? Wow. Right. So now let's take a look at type aliases. So in Kotlin, we can define a synonym to another type. Here I have type alias customer name equals string, which essentially means that anywhere there is a string, there is a customer name, and anywhere there's a customer name, it's a string. It literally is an alias. At runtime, there is no such thing as a customer name. It is just a string. The reason that you would add this is to provide a bit more in terms of semantics, right? Now, you can use this with anything. So, for instance, I can create a type alias that is, for instance, a function handler, and the function handler is of int to int that returns an int, right? Or by function handler. And then we've got Java. A lot of people use this. My downside of using this is that if I start to use by function handler in my call sites, I don't know exactly what this is, right? I no longer know that this is a lambda, so I don't use it much. But there is one place where type aliases come in nicely. Take a look at this code over here, right? Let me just... Here, I have a class which is customer, and I've added this annotation to it, which is provided by Kotlin, which is called Deprecated. And I say customer is now called awesome customer. Right? And I've also passed in a parameter that says replace with awesome customer. So what happens now is that anywhere that I use customer in my code base, I'm going to get it crossed out, and the IDE is going to tell me that the customer is deprecated, right? Which is nice. And in fact, the replace with gives us something even nicer. Alt enter, replace with customer, right? And I can do a global search and replace with that as well. Now, the problem is that if I just do that, what happens? If I ship my code and someone is using this API, they're going to break it, right? Well, I've broken their code, so it's okay. We'll just charge them for a new version. I'm joking. So what you can do is you can do a two-phase deprecation. It's kind of like what we do with Kotlin, right? In the first phase, you add this, and in order for customer to still compile, you add type alias awesome customer equals customer, right? And then once you've got people migrated, then you can remove that type alias, and then just leave awesome customer. Okay? Right. So a lot of the functions that we've been seeing, or we'll see, let's go ahead and come here and we'll say Kotlin, some more functions. So main, val numbers equals 1 to 100, and then numbers filter those that are less than 90, and on this map times 100, and on this sort it by. Here, what happens is that this is all eager evaluation. So it will essentially run through an entire list to be able to evaluate everything and return the results. In Kotlin, if you want to do lazy evaluation, which basically means evaluate as needed, kind of the default in things like Haskell, what you can do is take any collection and say as sequence. And then as soon as you invoke it as sequence, this then allows me to continue to call my higher order functions on them. And the upside is that it's lazily evaluated, right? So this allows me to basically process infinite lists of values. And it will only be called until it needs. And think about it will, in a sense, be called in reverse order. If you have situations whereby you cannot have a collection and you cannot just do as sequence, then you also have a helper function which is called generate sequence, which allows me to generate an infinite amount of values, for instance. And then on this, I can do filter, and I can do whatever I want, essentially generating a collection, a lazy collection. Okay? So this used to be called as stream, and then Java came out with streams, and we wanted to not have that confusion because our streams behave similar, so we essentially renamed it as sequence. Okay, so one of the things that we've constantly been talking about in terms of Kotlin and what Kotlin allows you to do is type-safe builders, right? So if you ever Googled HTML builders Kotlin, you'll see that you can get the groovy HTML builders, but statically typed. So I have an element that's HTML, and that element HTML has a body, and all of that is statically typed. My colleague Misha showed you how you can do this with the DSL for Team City. Gradle announced over a year ago that you can now use Kotlin, Gradle script, or script Gradle Kotlin, or Gradle Kotlin script, script Kotlin Gradle, whatever they call it, which means that instead of Groovy, you can use Kotlin, right? Giving you all of the benefits of static typing. And the key thing here is that it's quite easy to create new DSLs with Kotlin, right? So let's go ahead and create something. So I can create a new file, and I can call it, for example, Express.js, right? And if you're familiar with Express.js, it's kind of like Sinatra, right? And Sinatra is a web framework. So I can start with a function that's called get. And get is going to take a path of type string, and then it's going to take a handler, which is going to be HTTP request and, HTTP request and HTTP response, right? And it's going to return unit. Now I'm going to create a class which is HTTP request, which has a property, for instance, the request has accept header, and we'll say it has also, I don't know, a length in case of a post or what have you, doesn't matter what. And I have a class which is HTTP response, which has content that we're going to set, and, for instance, a status code. Okay? So now when I use this, I do get home, and then here I pass in my lambda. So I could do request, response, and then, if request accept equals application JSON, then, response equals content blah, and response, and else we'll do response status code equals 405, right? And this says that I need to make this var. Okay? Now, okay, that's nice. Although I don't like this every time, and this is very much similar to JavaScript and very much similar to Express. Every time I have to write request response, right? I don't like that. So why don't we just do a class which is HTTP handler, which takes an HTTP request and an HTTP response, and then this one will change to HTTP handler. So now I can just pass in a handler, and then in here would be handler, and here would be request, handler, request, blah, blah, blah. But given that I can just use it, I'll remove this, and I'll make this it. Okay? And it. And it. What have I done wrong here, people? This should be it. 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 No. Val get HTTP handler. It's a single parameter, so I can refer to it with it. That's what happens when you live code. No, you are not going to beat me, my friend. I will be the request handler, request. Weird. Does anyone see my error? It? Weird. Anyway, don't worry. I have plan B. Where's plan B? Oh, where did I have plan B? Oh, there we go. Plan B. Right. Why is that actually giving me a problem? Okay. Never mind. Okay. Forget that. So, no, we'll continue. Don't worry. What I want to do, essentially what I wanted to do is I don't like this, all of this, Control Z. I don't like all of this. What type is incorrect? HTTP handler. The type is incorrect. Anyway, what I want to do is avoid this. Handler, and then access handler, and then access all of this, right? Handler, response, content, handler, response, content. This is what I want to avoid. And even if that worked with it, which I don't know why it's not working now with it, because it is a function with a single parameter, I want to avoid that. So what you can do with Kotlin is, instead of passing higher order functions, you can pass in what's called lambdas with receivers. And lambdas with receivers are essentially higher order functions that instead of taking functions as parameters, they take extension functions, right? So instead of HTTP handler like this, I can pass in an HTTP handler, right? And this now gives me an extension functions, which means that any lambda that I'm passing in here is what? It's an extension to the class HTTP handler. Since it's an extension to the class HTTP handler, it has access to the properties of HTTP handler. So in principle, and if this goes wrong, I'm just going to throw the laptop and go away, I could just remove this And I think I know what the problem is. Hold on a second. Get me new. Get me new. I bet you have defined get somewhere else and it's importing that. Okay, get, and now I can just do request. There you go. Request, accept, right? So I get rid of the handler prefix and I just have access to the properties. Because this is an extension function to handler. So I have direct access to this. Now, this is nice, but I want to go one step further. I don't want response like this. I want to do just something like response content, right? And here, do response status code. That would be much nicer. Problem is that I can't do this. Well, I can actually. I say create member function HTTP response invoke, right? So what I'm doing is, I'll tell you what invoke is in a minute. This is actually going to be an HTTP response extension, right? And you see this now compiles. Ba-bam. Good? It's like I'm standing here sweating and you people are just like, okay, big deal, he got it compiling. So what this is, invoke is an operator that essentially allows you to invoke an instance of a class as if it were a method. So here, for instance, you see I have an invoke, I have a foo class, and I can define the operator invoke. So now when I create an instance of a class, I can invoke that instance and pass in any parameters I want. In this case, what am I doing? I'm passing in a response. I'm invoking response, but I'm passing in as parameter to invoke another extension function. Okay? So that now allows me to, again, have access to the HTTP response, HTTP response properties. And if you see, this is essentially how we're creating like DSLs, right? You're just using extension functions, lambdas with receivers, the invoke, and some conventions in Kotlin, such as the last parameter to a function. When it's another function, you don't have to pass it inside the brackets, etc., allow us to create these nice kind of DSLs. Okay? So, some other things that we have. ADTs, right? In Kotlin, you know that by default, you need to have a class open to be able to inherit from it. So if I define this as class, I can't inherit from it. But notice that if I put the sealed keyword, I also can. What's the difference between sealed and open? Sealed, what it's saying is that essentially the hierarchy is closed to this file, right? Meaning that if anywhere else I define a new type that inherits from result outside of this file, it's no longer going to work. And this is how we use, how we kind of define ADTs in Kotlin. And ADTs is algebraic data types, which essentially means a type can be of one type or a different one, right? So for instance, a Boolean is a true or a false, right? And why is this useful? It looks very pretty on code. But what it's useful is it allows me to do better kind of error handling, right? So for instance, function, get some page, get page, and then I have a URL string. And now what I can do is return an actual result, right? And I say if URL is not empty, then return result. And here, let's give it some meaningful names, because otherwise it feels like we're programming JavaScript. Status code, right? This means that I now return message, for instance, result, sorry, success, and else return failure, right? Failure. Status code. 404. So now when I do when, let's say val x equals get page, something, and I do when x is success, then when it is success, then print line x dot message. And you see that I get the auto casting, the smart cast, because it already knows it's of type success. And when it's a failure, then I can get x status code, right? And this gives me more semantics based on error or not. Now, an issue here is that if I were to add another one, which is called class semi-failure, that inherits from result, nothing warns me about this. One thing that you can do to avoid this situation is always try and use ifs and whens as expressions. So if I say the result value here, now you see that it's saying it's non-exhaustive. I would have to also add the else branch or the case in which it's semi-failure. Okay? And by the way, talking about results and returns, let's take a function that fails a lot, right? And then I'm going to do, let's say, that's going to be a unit, and it's going to throw exception blarg. Okay? And now, let's go to main, and we'll say, let's remove this to fails a lot. And I'll say, let's say, val x equals if args psi count is greater than 0, then return 20, else fails a lot, right? So I'm using if as an expression, okay? Now I'm getting a little warning here. Why am I getting the warning? Because what is x? X depends on the branch of the if, right? X can be 20, or it can be unit, because fails a lot is returning unit, which is the same as removing it. Now, I want this to be an integer, but Kotlin is casting it as any, because this line of the last line, remember the last or the only line of an if expression returns the value. So this one is returning the value of 20, and in this case, it's returning fails a lot. The problem here is what? Technically, it's correct because the compiler is saying I either return an integer or I return a unit, and unit is a valid type in Kotlin. But if you look at this function, what does it return? What does it return? Tell me. Who said exception? It doesn't return an exception. What does it return? Say the word. Louder. It returns nothing. Right? It doesn't return anything. So why don't we tell the compiler that it returns nothing? And now the compiler knows that that's always going to be an integer. Okay? So what is nothing? It's nothing. Nothing is the lower level of the whole class hierarchy of Kotlin, and at the very top you have any. Okay? So that allows you to be more explicit and then also detect things like potential dead code or unreachable code, because you know that that exception is never going to return. So if I write here fails a lot, you see that it says this code is unreachable because that method returns nothing. So there's a difference between unit and nothing, but as I always say, it's nothing to worry about. Very bad joke. And I don't have time to cover all of this, but I would recommend, if you are interested, to look into coroutines, which is something that we've released in 1.1 of Kotlin. And coroutines are a very fast way to, or very efficient way to do asynchronous programming. And just to show you, here I have 100,000 threads that are being launched using coroutines, using threads in Kotlin. And if I were to run this, what do you think the result would be? It takes forever? No. It won't be able to create 100,000 threads. You see? I get unable to create native thread, right? Now let's run the same thing with coroutines. what do you think the result will be? Well, it's going to work, otherwise it'll be a really crappy demo, right? It works, right? They're lightweight threads. And in fact, I could even come and create 1 million coroutines. And that would also work. So coroutines are based on the concept of suspendable computation. They're not a new concept. They've been around from the 70s or so. And that's how we do asynchronous programming in Kotlin. If you're interested in that, I recommend you start reading the coroutine guides on GitHub, which are fantastic to get started. Okay? Thank you very much.